functions, they have a degree. The degree is the highest power of the variable in the equation. So in this one, negative 2x cubed plus 3x to the 5, the highest power is an x to the 5, so the degree is 5. And we're going to be looking at graphing these. Okay? Another important definition is the leading coefficient. That leading coefficient is what we're going to use to figure out its end behavior. So we start looking at some patterns. Okay? We'll look at degree 1, degree 2, degree 3, degree 4, degree 5. We'll write some notes off to the side. Okay? In fact, you have some space. You have some space at the top of page 39. Let's add this note right now. There's something else here. Okay. So in that space at the top of page 39, I want you to write the following. Odd function. So this is a polynomial function with an odd degree. So in other words, the biggest one is an odd number. Okay? The end behavior of all odd function is like a line. You know that y equals x is your first odd function because it would have a degree of 1. How do you graph y equals x? Has a positive slope? It looks like this. The end behavior is what happens at the ends? Well, it's going down to the left and up to the right. But if you had a leading coefficient that was negative, so if you graphed y equals negative x, well then your slope is negative. It goes down from left to right, meaning that your end behavior is up to the left and down to the right. You know how to graph a line. Now you know what the end behavior of every odd function will look like. And we'll look at examples to see that. So if we wrote a definition for an odd function, any guesses what the next definition we're going to look at is? An even function. Right? Polynomial function. With an even degree. And what's the very first even degree that we graph? Is y equals x squared, a parabola. And the same thing here, the end behavior is like a parabola. So if we have an even degree function that has a positive leading coefficient, right, our parabola opens up, meaning that your end behavior is going up in both directions. And if you thought about a parabola with a negative coefficient, well, that's a parabola that opens down. The end behavior, what happens at the end of the graph, is it goes down on both sides. So here we get to look at some of our examples. First one is a line. Well, you know how to graph lines already. It is an odd degree function. So lines, end behavior acts like lines. Makes sense. If it's a positive leading coefficient, the end behavior, which you should add arrows on the end, there it is. And if it's a negative coefficient, well, it goes down from left to right. There's the end behavior of our line. Okay, quadratic, x squared graph, that's an even degree. Again, we know this already. If you have a positive leading coefficient, your parabola opens up. A negative leading coefficient, your parabola opens down. But now we get into the ones that are new. So if we look at a cubic, it's an odd degree. Positive leading coefficient, we think odd degrees act like lines. If it's positive, the end behavior should look like this. Does that match up on our graph? Yes, it does. But it has extra fun stuff happening in the middle. Maybe a bend, maybe a hill and a valley like this. This one just sort of has a tiny little hill and a tiny little valley. But the end behavior acts like a line. Same thing here. If you think of a line with a negative coefficient, end behavior is up here and then down here with extra stuff happening in the middle. Okay? So right now, if you were asked to graph x cubed plus 2x squared plus x minus 1, the only thing you would know is that, oh, it's going to start going down there and end over there, and I have no idea what's happening in the middle. Maybe that, maybe a little bit, but right now that's all we know is the end behavior. Go to an x to the 4 graph. Okay? It should act like a parabola. So a parabola with a positive leading coefficient opens up. Sure enough, that's where this graph ends, opening up. We're not concerned yet with all the stuff happening in the middle. A negative leading coefficient, we're going to think about a parabola opening down. Sure enough. I don't know, this was a bad idea. And then finally, the odd degree polynomial function. Here we've got odd, so it acts like a line. Sure enough, that's where our end behavior is. And if it's negative, there's our end behavior. So in the textbook, on the next page, they've explained this in a complicated, I think, way. Okay? Odd degree functions. The way that I've explained the end behavior for you is like a line. So if you can draw a line with a positive slope, then you know that here's your end behavior. If you can draw a line with a negative slope, you know there's your end behavior. Okay? I think that's easier to remember and memorize than, okay, as x goes to negative infinity, the graph falls to the left, and as x goes to infinity, the graph rises to the right. All of those words, that little picture that we just drew, describes it right away. Same thing with negative infinity. They've got a long-winded description here. If you can remember that odd degrees act like lines, you know exactly where the end behavior is. Same thing with even degree. What did we learn? Positive acts like a parabola. That means positive parabola, they're both opening up. Negative parabola, they're both opening down. Here's the longer explanation. As x goes to negative infinity, the graph rises to the left, and x goes to infinity, the graph rises to the right. It's good to be able to read that and understand that, but as far as remembering that, these pictures is a lot quicker and easier to understand. Okay, so in example 1, they want you to graph these. And for graphing them, what we're going to do is we're going to start by saying, I know the end behavior. This is odd, x cubed makes it an odd function, and it is a leading coefficient that's positive. That means it's going to end over here and over here. Then to fill in the rest of the graph, right now, all I'm going to get you to do is plug in values of x. If x is 0, figure out what y is, right? 0 cubed minus 3 times 0. Plot that point. We got 0, 0. Plug in 1. 1 cubed is 1, minus 3 is negative 2. Plug in that point. Do about 5 points. And once you've got the 5 points on either side, this one is going to be negative 1, negative 4. Once you've got a couple points, join them up, woo, and get an idea of what your sketch looks like. I did that really quick. I probably should have had a few more points to be more accurate. But join your points together and then connect it to your end behavior. Same thing with the next one. You know that your end behavior, it's even. It's going to go down here and down here. Plug in some values for x and y to get some more accurate points. The more points you do, the more accurate your graph is. But once you get a feeling like, I think I'm pretty close enough, connect the dots and draw your curve through them. So you're going to do this example, and then in your homework, questions 5, 6, and 8.